Thank you. So I'm basically interested in like pretty fundamental processes that we've been discussing throughout most of the talks since yesterday. That is essentially how do cells store information about who they are, what they need to do. At the same time, how do they communicate this information to their neighbors in telling them what they should do for the first cell's survival. So in the first storing information, they've stored it in multiple levels, as we've been talking about, on the genomic level, epigenomic level, transcriptome, and the proteome. For communication, they would use not just these, but also others, but mainly physical contact in pushing the other cells around, or also secreted factors, including RNA and proteins like cytokines and extracellular matrix. One of them that is not very much studied is extracellular matrix, which we haven't heard of throughout these talks yet. So the question is, can extracellular matrix contain information about cell states, and can it communicate this information to other cells that would then get on this ECM? So the model system we're using are fibroblasts, which are quite versatile, in a way that when there's an inflammatory situation or an injury, they would get activated. And also, they secrete certain cytokines and extracellular matrix abundantly, and they would also remodel this extracellular matrix, thereby changing both the biochemistry and the biophysics of the tissue. So it's also known that they're quite heterogeneous cell type, that two major types of these fibroblasts could be myofibroblasts and inflammatory fibroblasts. Myofibroblasts are pioneers at secreting increased amounts of collagen and remodeling it, and inflammatory fibroblasts, they communicate with immune cells by secreting cytokines and changing the immune cell's fate. So here we're using like Optogenetics to toggle around with these different cell states of these fibroblasts. So essentially, when you shine light on these cells, but thereby activating specific signaling pathways like TGF-beta, FGF receptor, and also Traf6, which is an NF-kappa B downstream unit. So thereby, we are sending these quiescent fibroblasts into different cell states. And also, the question we asked is, what kind of extracellular matrix do they make? So here, I'm showing you the kinds of ECM, the diverse kinds of ECM that individual lines that have originated from the same point make at the end of light exposure. So this is just a staining for collagen. At this point, I would go back to the question that I asked in the beginning, and I hope I have teased you enough. So if you want to know the answer to this question, please come to my poster and we'll talk about it later.